something changed. On October 29, 2025, the interstellar traveler known as 3I Atlas reached its closest distance to the Sun and then did something no one expected. Astronomers are still trying to make sense of it, and what they've uncovered so far is forcing some to ask questions they never thought they'd face. This isn't another ordinary comet gliding through our solar system. This is an object that spent billions of years adrift in the cold void between the stars. And yet, it's behaving in ways that defy every model we have. As 3I Atlas approached Perihelion, the point nearest the Sun, its brightness didn't increase steadily, as comets normally do. It erupted. The light output suddenly doubled. The rate of brightening was twice as fast as before. Astronomers Chi Chang-jung from Lulin Observatory and Carl Battams from the U.S. Naval Research Laboratory captured the event in real time and had no immediate explanation for what they were witnessing. Think about that. An object that's been voyaging through interstellar space since before our solar system existed suddenly flared to life in a way no one anticipated. Spectral readings showed something even more intriguing. The comet's light shifted bluer than the Sun's own spectrum. That indicated the presence of diatomic carbon and amidogen, C2 and NH2. Compounds tied to active ice sublimation. But here's the unsettling part. Radio data revealed that in the 2 weeks before perihelion, 3I Atlas was losing 5.7 times 10 to the 28th water molecules per second, about 40 times more than just a month earlier. One scientist compared it to a fire hose at full blast. Comets do become more active near the Sun, that's standard physics, but this was different. The timing, intensity, and pattern of change didn't fit anything we've seen from comets in our own system. Space-based observatories, SOHO, Stereo A, and GOES 19, recorded the comet as it passed close to the Sun. What they saw was peculiar. A glowing, stretched-out object with no visible dust tail. That absence is significant. Comet tails are formed by dust, but here only gas seemed to be escaping. One theory suggests that earlier carbon dioxide sublimation had created a cooling layer on the surface, temporarily shielding the water ice underneath. When that CO2 layer dissipated, sunlight struck the exposed ice directly, triggering the explosive brightening. But others think the truth might be deeper, literally. Since this object didn't form around our Sun, its nucleus could be composed of materials utterly unlike anything we've ever studied. The James Webb Space Telescope took a closer look, and the data changed everything. Using its near-infrared spectrograph, Webb detected that 3I Atlas's surface had been radically altered by billions of years of cosmic radiation. According to astronomer Romain Majolo from the Royal Belgian Institute for Space Aeronomy, relentless cosmic rays have reshaped the surface of the comet up to 15 to 20 meters deep, forming a hardened, irradiated crust, nothing like the pristine material it once was. That means what we're seeing isn't a preserved relic from another star system, but a body transformed by interstellar travel itself. As Majolo put it, 3I Atlas is now the product of its journey, not its birthplace. That raises a new mystery. What lies beneath that ancient shell? Could the untouched interior still hold clues to its original star system, untouched chemistry from another world?
Harvard astronomer Avi Loeb, known for his work on Oumuamua, has formally requested that NASA release all 3I Atlas data to the public. Why? Because this isn't just another comet. It's only the third known interstellar visitor in human history. And the data we collect now might redefine what we know about the objects drifting between stars. So far, NASA's missions, SWIFT, SOHO, STEREO, and GOES have gathered terabytes of observations, but not all of it has been released. Loeb's argument is simple. Science thrives on transparency, and an event like this demands global collaboration. As of now, the comet has passed perihelion and is moving outward, slowly becoming visible again through telescopes on Earth. Astronomers are watching closely to see whether its brightness fades, stabilizes, or grows even more erratic. If the surface has eroded enough, we might soon glimpse the untouched material beneath the irradiated crust. But not everyone believes this is just a natural process. German astrophysicist Susanne Paltzner has proposed something revolutionary: that interstellar objects like 3I Atlas could be planetary seeds, the first building blocks of worlds that never formed. Her models suggest that young stars can capture these objects using them as gravitational cores around which planets coalesce. In other words, interstellar debris might be the missing link in how planets form. 3I Atlas isn't just strange, it's ancient. Estimates place its age between 7 and 12 billion years, older than the Sun, older than Earth, older than every planet in our solar system. It has crossed the galaxy at over 130,000 miles per hour, possibly surviving encounters with other star systems, radiation fields, and gravitational tides. The fact that it remains intact is astonishing. Its hardened crust may have acted like armor, a natural shield forged by radiation, preserving what's inside for eons. And that leads to an unsettling parallel. If one were to design a probe capable of surviving billions of years in interstellar space, one would make it look exactly like this: inert, shielded, and capable of activating under specific conditions. Some researchers have noticed that the outburst occurred exactly at perihelion, almost too perfectly timed to be random. Most comets brighten gradually, not in sudden synchronized flares. Could this be the result of a threshold mechanism, natural or otherwise, that activates under a precise level of solar radiation? Loeb and others caution against jumping to conclusions, but they argue that refusing to even ask the question is unscientific. If something behaves in a way that mimics engineering, activation thresholds, resilience, and symmetry, then that's a hypothesis worth testing. 3I Atlas will soon fade beyond our reach, heading back into the darkness it came from. We may never see it again. For now, telescopes worldwide, on Earth, in orbit, and even on Mars, are still watching. Data continues to stream in. Each new observation is a puzzle piece in a mystery billions of years old. Maybe it's just a comet behaving in unexpected ways. Maybe it's something more, a relic, a message, or a remnant of a civilization long gone. Whatever the truth, this moment matters. Because what we're witnessing isn't just the story of one interstellar object. It's a test of our own curiosity, of whether we dare to follow evidence even when it leads us into the unknown. For a few fleeting weeks, the universe has handed us a riddle, a visitor from the stars, behaving like nothing we've ever seen. The question is simple. Are we paying close enough attention to understand what it's trying to tell us?